Hello and welcome. Today we're going to be talking about scanning in a new bite, and this is a presentation that I had all across Canada last year, and my wonderful fans have requested a recording of it many times, so I'm finally sitting down to do a recording and walking through it at a nice slow pace. There is a section of the video that is strictly just the copy reuse CAD, and you can skip ahead using the clips labeled in the video. Okay, let's just get started. So some of the things that we spoke to was understanding how 3Shape works and some tips on the bites, using the virtual articulator, keeping in mind this is not using the 2024 update, scanning in new bites, and some alternative workflows for scanning in new bites. So we need to start with understanding the work order of 3Shape. When you're working on a work order, there are three things that 3Shape is considering. What information are you inputting? What tools do you need to design? And what is your output information? So when you're actually setting up your work order, what is being scanned? How are you scanning it? Is it models, impressions, a copy denture, reference denture, triple trays, wax rims, digital models? Are you scanning with an intraoral scanner, a 3Shape bench scanner, or an outside bench scanner? What design module are we using? Are we designing something in the denture module, in the removables module, the crown or bridge module? And what tools do we need when we actually get in there? Are we going to use the articulator? Do we need a coupling mechanism? Do we need all the transformation tools, etc., etc.? The last thing that you're telling it is what files you're actually producing. Do you need a monoblock? Do you need split files? Are you using carded teeth? What type of file does your equipment need? STL, CAM5, PTS, there's a bunch of different file types. So all of this is information that you are determining when you set up the work order. And the foundational denture workflow, that's where we're going to start. How this was originally designed to work. You would scan in either models or impressions on a 3Shape bench scanner, and you would end up with virtual models like this that are articulated together. From there, you would have a monoblock output. This would be your try and design, and it would be all one piece solid. This was the only option at the time. And you would be using your standard material settings. Now, when we talk about material settings, so when we're selecting, for example, this one is PMMA, there's a lot of things in the design that is actually accommodating for. Things like the connector settings, things like the minimum thickness under the teeth, the coupling depth, the coupling angle, sometimes the gingival settings, sometimes the minimum base thickness. So depending on what material you're selecting, these settings can change. It's also going to change some of the settings for which files are being produced, be it an STL file, a PTS file, a 3OX file, whatever files you need depending on how you are manufacturing this. So you might see some videos where they set up the work order for a very specific library. That doesn't mean that you cannot manufacture a denture if you don't have that exact same library. That library might just have some settings attached to it from that manufacturer. So if you're making a Lucitone denture, for example, it's going to have a recommended minimum thickness that works best with that material. Now, if you don't have any of those materials, every 3Shape system comes with this PMMA material, which is a safe standard material for a majority of dentures. So once we actually set up our work order, we have to understand a couple things when we're looking at our bites and why are our bites always off and how can we actually accommodate this in 3Shape. So before we even scan in a new bite, our initial design, we need to understand why things are working and why things aren't working. So one of the things that I like to do every time I start a case is I actually like to bring in all of the data that I have. Sometimes I'll add extra scans, sometimes I'll scan them in with extra scans, and then I like to do a 2D cross-section and just make sure that everything is lined up correctly, especially if I'm finding a lot of my bites are off or my practitioners are always complaining about the bites. So here in this specific example, you can see that upper denture is not aligned to the model. So is the bite off in the model alignment, or are these two files not aligned? Something is misaligned here. So this should set up a red flag, and we need to go back, check our scanning alignments, check that everything's aligned correctly, make sure that our initial setup has the correct byte. Once we are actually at our setup, so this is at the tooth setup stage, there is a virtual articulator. And I'm going to run through a couple of the ways in which we can use this virtual articulator. So there's this little black arrow here. You can actually change which articulator you're using, and there are a few pre-built articulators in here. So depending on which one you're using in your lab, you can use the exact same one on the screen. Most of the people who I work with are using this articulator here. In the top right, when we go up into this button here, we can now look at some of these excursions. We are in the tooth setup stage. So all we can do is look at some of these excursions, but we can hit the little play button there and it's going to run left side, right side protrusive. What I like to usually check at this stage is that I have a decent protrusive. We cannot cut contacts at this stage in the design. We can do that at another stage. So you can see here, we're just zooming in and we're running through all of the different movements with our articulator. Now what if I just wanted to check one specific movement? I can click on these arrows and I can just push it into the movement that I want it to be moved into. So I want to look at the protrusive and I really want to see what things are going on when I push it into a protrusive byte. I can zoom in, I can push it further and beyond and see what's going on. Keeping in mind, we have not cut the centric byte at this point. So if you have really heavy centric contacts, they might be interfering. So this is just acting as a general reference to see where everything is set up. And we can do left to right, we can do side shifts, and when we do that, it's going to give us these little blue markers. There's a little disc here. When you click it, it changes the colors from blue to different colors depending on what movement we're doing. So the protrusive is going to turn black, and then one direction is blue, one direction is green, and I believe red is your centric contacts. So if you want to actually see the different colors while it's moving, you can do that too, just by clicking that little disc on the screen. Now when we get to the step here in the sculpt anatomy step, this is where we can actually cut in the centric contacts and we can cut in our movements. And so when we were designing this, maybe we purposely set some contacts a little bit heavy, especially if this is for a single arch, or maybe the way the library comes in, you want your contacts to be a little bit broader. For this example, I made the contacts extremely aggressive just so we can visually see exactly what's going on. So if you look at these two here, they are crossing over. Now in the real world, they would not cross over. This would be holding the byte open. When we're cutting bytes in a digital software, there are two ways where we can cut in the byte. One of them is sometimes referred to as a Boolean difference, and I'm just going to pause this while I explain. And the Boolean difference is acting more as a chop, an actual slice and a cut. And you can see that when you use the Crown and Bridge software or the removable software, you usually have two options when cutting in your occlusion. The other way that you can cut two objects from each other in a digital software is more of like a subtrusion, or there's a lot of different words for it. But what you can imagine is we're not actually chopping out this exact shape out of this. What we're going to be doing is kind of pushing that shape into this. If you can imagine you have Play-Doh in your hand and you're pushing your thumbprint into it, it's still leaving the impression of your thumbprint, but it's not actually chopping out a perfectly sized version of your thumbprint to rest inside of. And also, additionally, if you look here, these little arrows on the left side of the screen are pointing to which arch we're working on. So you cannot do the bull method or the lovely method or whatever you learned in school for cutting in your centric byte. You have to either cut off the upper or cut off the lower. My preference, as I was typically doing a lingualized setup or something similar, would be to cut any heavy contacts off the lower. Now, this example is very extreme, and you're not going to be cutting that extreme typically, but I don't like to cut off the upper because I don't want to cut that cusp off. I would rather be cutting a little bit into the centric fossa and cutting it that way. That's just a personal preference. So let's resume this little sample video here. So here, in the contacts and smoothing, the desired distance to antagonist. The antagonist at this point is the upper, and I want that to be 0. I want no distance because I want it to be cut to the VDO that I have set on my articulator. And now as I slide along here, you can see it has pushed into the lower the shape of the upper. It's not a complete chop of the lower, and I'm going to do an occlusal view so you can see the difference. Again, this is a very extreme example to show us what's happening. I would not normally cut this much off, as it would probably lock you into the bite. So if I do an undo and a redo, and you look at that occlusal surface, you can see what it's doing. It's not getting rid of all the anatomy. It's pushing in the opposing contacts. Once the centric bite is cut, then you can also cut in your excursions. Now this is optional, and so what we have to do is turn on the articulator, make sure that it's mounted correctly still. And if we click on that little top right button, there, then we come into our little excursion mode just like we did before, and now that we have cut our centric bite in, it's actually going to give us a more realistic view of what's going on. So it's going to go left, it's going to go right, it's going to go forward, and honestly it goes very far left and right. And even into the protrusive, it does go pretty far. So I like to turn off the visual of the articulator, and I like to turn off my upper, and then I like to just have a look at the contacts. So we can see here, it's really not contacting in that many places, probably because these were intersected so deep. And so now we have the option to adapt the designs. So what it's going to do is cut in the contacts of all of those areas that were marked. And then we can hit play again. You can hit play as many times as you want, and it's not actually going to cut in the contacts. And we can see here there's a cut contacts by 0.1 of a millimeter. That's how much it's cutting in your contacts. I'm just going to pause it for a sec. It's cutting in your contacts only by 0.1 of a millimeter. So you're basically taking a little burr and going into all of these contact points, but it's an exact amount. So some people will say, make sure you do this 3 times on the upper, 3 times on the lower, and it's the perfect bite. For me, I check the case. It's a case-by-case basis. Sometimes I'll do it twice. Sometimes I do it once. Sometimes I do it 3 times. What I'm looking for is balanced occlusion. So what I'm looking for is that it's going to be the same type of reading on one side as it is on the other. And also what's very important for the practitioners who I worked with is the protrusive. We really want to make sure we have a balanced protrusive. So the black markings is showing your protrusive. So right now we have a little bit more in the front here because we did cut this once, and we have a little bit more sitting in the back. So I'll hit play and I'll let this keep going. And I don't even usually keep the colors. I like to keep it in blue, and we can hit adapt designs again, and then we'll hit play one more time, and it's going to run through all of those motions again. Again, this example was including an extremely aggressive centric bite that we cut in fairly deep. So the way that the contacts are moving here isn't quite the norm what I would normally do. And if I really wanted to check this and just double check everything, once I have cut everything in, once again, I could go into that protrusive bite, and I can push this forward and just see where I'm contacting. So you cannot do this in the tooth setup. You have to do this in the sculpt anatomy step. This is where you're going to be cutting in on your contacts. Make sure you are always, always, always cutting in your centric bite. You never know if there's a couple facets of your design that are just too high or too heavy in one spot. You don't necessarily have to cut in all of your excursions every time, but you should always be cutting in your centric bite on one of these arches. This is going to make sure that the bite that you have on the articulator and the VDO you have on the articulator is going to be exactly the same as your finished design. So that was just a couple of tips in actually getting a decent bite the first time. Now, once we actually have our case finished and designed, and we send this out for trying, what are we manufacturing? Again, this is assuming a traditional standard workflow where we would set that first work order to monoblock. This is before we had some of those other options that we have today. We're starting at the foundations. So we would have a monoblock upper and lower denture. Where is 3Shape housing this information? So if we go into our File Explorer, and I say this in the kindest, nicest way, File Explorer is part of your Windows computer. This is not a 3Shape app. This is a Windows application where every file on your entire computer is housed. Now 3Shape will output files into your File Explorer. And it's going to do that in 2 locations. There's a case file directory. This is where you can find your primary information. It has all of the materials you use, every button you clicked, has all of the information that we put in, our scans, our models, everything like that. And then we have our manufacturing output. So in your File Explorer, you will see this case that you designed in 2 separate locations. One is just the general file directory, which is typically on your C drive, but if you have a different network set up, it might not be. And then the other one is in a manufacturing folder. Again, if you have the standard setup, it'll be in a folder called manufacturing drive. But if you have a network setup that's a little bit different, it may be named something different. Now in the case file directory, this is where you're going to find DCM files. So there's a folder here that says CAD, and in there you are going to find the design of your case, but these are DCM files. These are 3Shape specific files. You can't print that and you can't mill that. And so that might be what it looked like. In that CAD folder, you're going to have a full upper design and a full lower design, and they are going to be articulated together in the right X, Y, Z space that they were when you designed them. When you actually go to print or mill, this try-in is going to be in the manufacturing drive. Now everything in here, these files are determined by what material you selected when you set up the work order. So majority of the time, they're going to be an STL file. If you're using a specific file type, you might see files named CAM5, or for this example, you have 3D point cloud, which is also a PTS. You might see a 3OX. There's a lot of different ways that these files could be released from the software. So if you're setting it up just using that PMMA material that we had selected, this is what you might see when it comes out. And you can take these STL files and you can put them in your printer or your mill. Now, when we actually look at these, they're no longer in that occlusal alignment when we designed them. These are actually coming out prepared to put into your nesting software. There are some milling and printing softwares where you cannot turn your object 150 or 180 degrees around. So they need to be coming in relatively flat so we can put them into our puck or put them into our build plate and nest them a lot quicker. So the files that are in your manufacturing drive, these are for manufacturing. And they're not going to be output the same way as the files that are in your other folder. This is important to know if we really want to understand what's happening when we use the Copy Reuse CAD feature. So we have completed our design. We set up a work order. We made it with dentures. We used standard denture materials. We're going to output a monoblock. We scanned models or impressions on a 3Shape bench scanner. And we output a monoblock file in the case directory and also in the manufacturing drive. That's how we got to the point where we are right now. We sent that to the dentist. They tried it in. The bite was wildly off, and they sent it back. What do we do? So when we are ready to scan in a new bite, there is actually a feature built into 3Shape that's been there for a while. I believe as early as 2019, potentially even earlier. That's as far back as I can recall. And it is called Copy Reuse CAD. So we're going to find the original case, and I do have a video walking through this entire process that I'll show here in a minute. On that original case, we're going to go to Copy, and there's a button there that says Copy and Reuse CAD Design. This is going to prompt the software to scan in a new bite. So what it's going to do is it's going to give you this little warning, and it says the denture has been created, use the modify function. So it's actually making an entirely new file for us to work off of. And when we go and look at that file, there's going to be notes in the comment section. So this case up here was our original Ream 1337. And this is the case that it created. And then in the bottom, because we clicked that button, it's going to say align and reuse design from order 1337. So if we ever forget, like, oh no, I have 25 of these cases from the same patient because it's been a nightmare, which one did I just do? It's always going to be in the bottom in that little comment section. And if they sent it out again and we did another Copy Reuse CAD, it would stack that on top of here and you'd see that again, another Copy Reuse CAD on top of that. And then we'll have the option to scan it. So we're going to right click and we're going to click scan. And then what's going to happen in the software is it's going to prompt you to put your two try-ins into the occlusion. So you have some kind of a bite, a putty bite or something, put them in occlusion. And this one, I typically scan my bites in upside down because it's a little bit easier for me to stick the upper palate to the plate. So these need to be in their new occlusion, not on our articulator. We don't need to re-articulate this, just as they are. And we're going to be able to align these to our previous design. And now we can see we've aligned it to our previous design. So what we did was a copy reuse CAD, we right clicked on it, click scan, and on our 3Shape bench scanner, we scanned in that new bite while they were stuck together. We aligned it to our previous design. So what is it actually doing when we're doing that? We saw it in there. It's aligning to the previous design. So it's pulling the monoblock DCM file from the CAD folder of the original design. So if you're interested in what's happening in the background, this is just nice to know exactly what's happening. It's going to pull the upper and the lower and all the data associated with that, what clicks we had, what libraries we used, how we designed this, and it's pulling the previous design from this CAD folder, not from the manufacturing directory, because those ones, remember, are no longer aligned. There's no extra data attached to them. They are just for manufacturing. So once we've done that, we can go through the whole design and we can redo things and everything's going to be the same. And we're going to go through one here in a minute. But what if your original design is set to digital impression? So the first time we designed this, we designed it as a digital impression. So what does it look like? Your first design was set to digital impression. We don't have a bench scanner. We're using intraoral scans, or we have a different brand of bench scanner, and we're pulling everything in as digital impressions. We click copy reuse CAD. It creates a new case. We right click to scan, and there's no options. The only option is to import the scan. Now we could click this, but this requires you to have all of your data, so your new data, your old data, everything aligned. And that's very difficult to get. It's very difficult to align everything. There's an easier way to approach this situation. All you need to do on that new case, so we did a copy reuse CAD of this case here, and this case here, we didn't have the option to scan in a new bite because all it's saying is import scan. So we're going to click modify, change the order to model, click OK. So we're going to change it from digital impression to model, and in that work order, we're going to click OK. And now when we right click on it, we have the option to scan. So then we can right click and scan, and we can scan in that new bite on our bench scanner. And I know what you're thinking, I don't even have a bench scanner. That's why I set it up as digital impression to begin with. You do not need a 3Shape bench scanner to use the Scan It Dental app. When you purchase 3Shape, it comes included with the scanning app, even if you do not have a 3Shape bench scanner. And this app is used for a whole bunch of things. So we can celebrate. So you're going to right click, you're going to click scan, and it's going to open the scanning app. And when it does, there's going to be a little folder on the bottom left. That's what this little image is. It's of a folder. And when you click on that, you're going to be able to import whatever bite scan you have. So maybe you have a Trios bite scan of the new bite, or maybe you have a different bench scanner and you scanned in the new bite. As long as you have a file of your upper and your lower and they are in the new bite, we can import that in. And then we're going to align it all and we're going to redesign it. So let's walk through this together. We're going to do a video here. So we're going to start, this is our case here. We're going to right click, we have a new bite, copy, reuse CAD design. It's going to give you a little thing that says, okay, blah, blah, blah. And then we're going to go find that new order. It'll typically be right at the top of your today or your most recent. And when we click on that order, you can see at the bottom, I'm going to pause this, at the bottom here, align and reuse design from here. So it's showing you exactly which one it is aligning it and redesigning it from. But if you look here, I have no option to scan in a new bite. I only have the option to import the scan. So instead, I'm going to go down to modify, and we're going to change this from a digital impression to a model. And then we're going to click OK. Now when I right click it, we have the option to scan. And now maybe I don't actually have a bench scanner, which for this example, I did not actually have a bench scanner. I already had the new bite scanned on with a STL file. So if I just click this little button here and I go find the new bite, I saved it on my desktop somewhere. So this is our new bite. I'm going to align the upper. And then I'm going to go in and align the lower. And once those are both aligned, then I can go in and I can redesign this case. So what is actually happening when we do the copy reuse CAD? So I'm going to click design and show you a couple of things in the actual design software of what's happening. Do you want to keep the design? Yes. So this is opening in an older version because the original case was designed in an older version. And that's okay. It still works generally the same, even with the most recent versions. So at this point, everything that we've designed is going to be in the same position. And so I can click next, next, next. Now, if your bite changed ridiculously drastically, you might have to change the boundary on your lower arch, because your lower jaw is what's changing. And when we get to the tooth setup, I will explain a little bit better exactly what's happening. So when we're actually in here, we're going to have some extra sliders now on the right side. And those extra sliders are showing us our previous design. So they're pulling that previous design from that CAD folder, and they're going to show us that previous design in the new bite. So the upper teeth are going to be in the exact same position that we set them before. Now these ones are looking a little bit longer, and that's probably because we did some adjustments in the sculpt anatomy step. And so once we go back and do that, then these will be the same height. But these upper teeth are going to be in the exact same position. The lower teeth are going to be set in the same relationship to the upper as we had them before. And so what is moving is the actual lower model. So if we look here, the upper teeth, as you can see, are set in the same position. The lower teeth are in the same relationship that we set them to the upper. So however they were occluding with the upper, you can imagine it like the upper and lower teeth are glued together in the exact same spot that they were. The thing that is changing here is the lower model position. So if you look at our old design, it looks like the teeth were set way further forward. It's actually because the model has moved a little bit. So our previous design is set up and aligned to where it needs to be, to our model. But our lower teeth are set to our upper in the exact same occlusion that we had before. And so if you had your articulator and you had opened the bite or closed the bite with the incisal pin, this one is not. I would always double check this, because this will now be applied to your new bite. So if we had opened the bite 2 millimeters on the original design, it's now applying that 2 millimeters to this new bite. So if we had any registration material or the bite was hitting heavy in the posteriors and it was already holding the bite open, we're opening it an additional or closing it an additional whatever it is to the current bite that we're working on. So my suggestion is to always go back in and zero out your pin and then work from there. And so at this point, you would just go ahead and make all of your changes. If you need to reset your teeth or check that you're over the ridge or anything like that. And when we get to that point where we had previously cut in our contacts, the sculpt anatomy step, it's very important that you click undo all. Because anything that we had applied before, it sometimes does not apply to the new position of the teeth. So very, very important. Make sure you're clicking undo all at the sculpt anatomy step, cutting in your centric bite again, and then cutting in your excursions again. Every time you scan in a new bite, you should be running through these steps. So there's two more alternatives that I'll discuss that I've seen people come up against. One is I didn't set the first work order as a monoblock, because now what we can do in 2024, and I think as early as 2021, when we set up a work order, we can have it output a monoblock and also a split file in the same work order. So when we're setting up our selections in the work order, it can output all of the things. What happens is that monoblock is no longer saved in our CAD folder. It's now saved in only our manufacturing drive. And so what that looks like is this. When we're setting up the actual work order, we've set it to base with design teeth as the type, or some other type that's going to automatically give us a tooth, a base, and a monoblock. So what that's going to do is I'll pull up the folders here and I'll show you exactly what's happening in those folders. So in our standard folder here, if we look at our CAD designs, we have a tooth file, and we have a base file, and then we have another tooth file, and another base file. We don't have a monoblock in this folder. So we're going to right click, we're going to do copy reuse CAD, and we're going to go scan. And when we try to scan it in, so we're going to bring in our new bite right here. Here's our new bite. When we try to align it, oh no, there's no teeth to align it to. And so sometimes this is really, really difficult to align these two scans. Typically what you can try to do is try to align it to the gingival, the little interproximal gingival areas. But what is normally happening with these dentures once we print them for try-in is you're probably going to polish them, or you're going to grind on them, and you're going to change. And if we don't have a tooth to actually align it to, it's very, very difficult sometimes to align these two data sets. So you can see the one on the bottom is kind of smoothed out, it's been polished, it's not an exact match, and so we have no tooth structure to align it to. So there are a couple ways in which you can try to align this. You can try to align it like I am here with the interproximals like this. If you do have a full complete scan, so let's say we made a dummy order and we scanned this in as a copy denture, all one piece, or we scanned the new bite with a trios, all one piece, you could align the tissue surfaces because they should be the exact same tissue surface, and that could help. But there are just some instances where it's going to be extremely difficult to align these two cases. Hello, this is the Pam of the future, and I lost the last part of this recording. It didn't save, so I'm re-recording it, but I have a much crappier mic, so please apologize the change in sound. So as I was saying, when we want to align cases like this and we don't have the tooth, you can see it's not going to align, yada, yada, yada. So what is actually happening when we are trying to align these cases? In our case file directory, this is not the manufacturing drive, this is a case file directory. We can go into our scans folder, and in that scans folder, there's going to be a folder called auxiliary scans. And this is where we're actually going to see that scan that we're aligning to. So the one that says lower full dentures CAD, that's going to be our lower one. And if we click on it, you can see it's the file that doesn't have the teeth in it. It's just going to be the base with the sockets. Now this was pulled from our design from our CAD folder, because remember, our CAD folder does not have the monoblock design, only the manufacturing drive does. So what we want to do is we want to just swap out this file for a file that is aligned to our previous design. Now if we just pull that directly from our manufacturing drive, it's not going to be aligned, and nothing's going to work because they're not going to be lined up. Because remember, in our manufacturing drive, they're no longer aligned to our design, they're aligned for manufacturing. So there's actually a secret button in 3Shape, and sometimes it's not turned on. And if you go to Advanced and you go to Export Visualization Output. Now, this is on the original design because we want the monoblock for the original design. This little tool, if it's not turned on your system, just call your reseller and ask them to turn it on. It doesn't cost anything extra. It comes included with your 3Shape, but sometimes it's just not turned on your system. So you're going to click on this button, and what it's going to do is create a new folder inside your manufacturing drive. And this folder is going to have everything from your design lined up in an STL format. So they're all going to be aligned in the right byte and the right XYZ position in a new folder. And that's where you can pull your file from to swap into your other file. So on our case, we're going to go to the manufacturing drive. In manufacturing drive, we're going to go to visualization output. And in the visualization output, you're going to see all of your files. So you're going to see your models, you're going to see your tooth, your base, your monoblocks, everything. So these two files here are the monoblocks of this case. And we can see that they are aligned in the byte that we designed them in. They are not in the same alignment that happens in the manufacturing drive. So what we need to do is just put these two files into the location of those other two files. And so to do that, we're just going to pull up our copy reuse CAD case here. We're going to go into the files together, into the scans, to the auxiliary scans, and we want to swap it out for this one here. This is your lower full dentures CAD in the auxiliary scans of the copy reuse CAD. So I'm just going to scooch that one over, pull up the other one, scooch it over to this side. And I want to make sure that I have the lower one because we're going to start with that one. So I'm just going to double click and make sure it is the lower one. And I'm going to move it over and then rename it. Check that it's lower, and then I'm just going to drag it into the folder where I want it to be. And then I'm going to copy the name of the original one because it needs to be spelled exactly the same. So I'm going to copy the name of that one, and then I'm going to delete it, and then I'm going to rename this one. Now all we did was swap out that scan for a scan that has the teeth and everything and is aligned in the original position. And now I can do the same here. So I'm going to make sure that it's the upper, and I'm going to drag it over, copy the name of the upper, delete that upper, rename this one. And I have a full upper. And I'm just going to click off of everything, and I'm going to go back into that copy reuse CAD, and I'm going to click rescan, and now you can see when I go to align these two, I have a full monoblock of the upper to line it up to. And from here you can go in and you can redesign it exactly the same. Now this isn't necessary. This is again a little bit more complicated, but if you like thinking out of the box or you like seeing other ideas to tickle your brain with, this is just one more way to work around this. That's all I have for you guys today. I am working on getting some more videos out there and hopefully with good sound all the way through. Thanks for tuning in. Leave a comment if you have any questions.